Okay, this is Organic Chemistry, Lesson 6, and we're going to finish up with Table R today. We're going to talk about organic acids, esters, amines, amino acids, and amides. Let's first start with organic acids. Organic acids have what's called a carboxyl group. It is a C double bond O, OH, sometimes also written like this. And it's always at the terminal carbon, meaning the end carbon. And we're going to take our parent group like propane and drop the E and add OIC and the word acid. So an example would be propanoic acid. It generates H plus ions in solution, and they are also called electrolytes because they have the ability to conduct an electrical current. So I was just talking about propanoic acid. You know that prop is 3 carbons, and on that last carbon you're going to put your double bond O, OH, and then add your H's. This C is completely full. Oxygen only forms 2 bonds. One is to the C, the other is to the H, and H only forms 1 bond. And this here, this is our functional group, this whole thing, the COOH, and it's only 1 carbon, so this is methanoic acid. You don't need any numbers in naming organic acids because the C double bond OOH, or the carboxyl group, is always on the end, or what we call terminal carbon. Esters, very, very similar to organic acids, except for they are only C double bond OO. They're missing that H, and they are embedded in the middle of the chain somewhere. Now, it's a lot easier to understand esters if we talk about esterification. Esterification is when an organic acid and an alcohol have a reaction to form an ester, which is what we're talking about right now, and water. And you're going to learn this reaction in the second half of this unit. The easiest way for me to explain what's going on is to show you an esterification reaction, but you don't have to know it just yet. So I'm going to take the reaction for the first one that we're trying to draw, ethyl butanoate, and I'm going to take butanoic acid. We just reviewed what an acid was. So I need but for 4 carbons. Acid means it's got a double bond OH on the last carbon. And I'm going to take ethanol, which is 2 carbons, and alcohols have an OH on the end. Now, the process of esterification is a dehydration reaction because water is formed. So, how do we get the water? Well, I'm going to take the H off of the acid and the OH off of the alcohol and form water. Now look what I'm going to do. I'm going to recopy what's left over here. I've got C, 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 double bond O and O, and then my H's. And then I'm going to take what's left here, which is 2 carbons and 5 H's, and add them on. So what I've actually just created is an ester. This is an ester. The last part of the compound came from the alcohol. So we're going to name this first. That's 2 carbons, so this is an ethyl group. And then this part here came from the organic acid. So we're going to name that now. 1, 2, 3, 4. So we're going to take butane, drop the E, and add OATE, butanoate, ethyl butanoate. So that's an ester. So I'm going to draw that up here in the box for you. So 1, 2, 3, 4. I draw it in a different color so you can see where we added the alcohol part on. Okay, let's name this middle one. Remember, we named the last part first. This came from the alcohol. It's only one C, so this is a methyl group. And then we're going to name this part, the first part, last. 1, 2, 3. That's prop. So propanoate. Drop the E, OATE. Okay? Now, just the way we take the last part and name it first, and we take the first part and name it last, we're going to do the exact opposite. We're going to take the methanoate, which is really the first part of the name, and you know it's one C, and off of that C you've got a double bond O. This is just missing one H. And then the first part of the name, which really came from the last part, is prop, which is 3 C's, and then all its appropriate H's. There you go. Esters are probably one of the most difficult ones to understand. Esters are known for their fragrant aromas, perfumes, flavorings like banana extract, almond extract. So actually, if we have time, we're going to actually make the wintergreen extract as one of our labs. We will have time. I'll make sure we have time. Okay, let's move on to amines. Amines, nitrogen alone with only hydrogens seen within the carbon chain. Amine group can be a branch off the parent chain, kind of like a methyl branch. You number the carbon with the amine group, and then you name the parent chain. We're going to take the E off like we have been doing, and then add amine. Name exactly the same way as you would an ether, except substitute the word amine for ether. So, prop. 1, 2, 3 carbons. And we can just put the NH2 right here at the end if we want. So 1 propanamine. And this one, we're going to have to number our chain. 1, 2, 3, 4, 5. So we have our functional group, our amine, off the second carbon. So this is 2 pentanamine. Pent because it's 5 carbons. Ethyl methylamine. So we're going to draw the methylamine first. So that just means we've got a C with an NH2 off of it. And I'm going to draw the whole thing here. Here's our NH2, and we need an ethyl group off of it. Okay, so here's the methylamine, and then we have an ethyl group off of it. Remember that nitrogen can only form 3 bonds, so don't get carried away with that. I believe you already have the picture in your book, but they drew it differently. They drew it like this. which is really the same thing as what I drew. I just changed bent the chain. Okay, amino acids. Amino acids are not in Table R, but they have asked them on the regions. You only need to be able to recognize them. An amino acid, amino comes from amine, has an NH2 group. Acid implying organic acid, so it also has a COOH group. You just have to recognize these. So here is the organic acid group, here is the amine group. So anytime you see, when you're looking at this, look for functional groups, and here's this. Okay, this also has an alcohol on it, but it's an amino acid. And here is, again, remember this is C here, so here's your functional group here, and here's your functional group. So anything with an amine group and a organic acid functional group is called an amino acid. Amides. Amides have an amine group, and they also have a double bonded oxygen. So you're looking for, it's actually two functional groups, and it can be either the terminal position or it can be connecting a parent chain to a branch. So it could have a number. Let's start with the terminal position first. Propanamide, so it's going to be 3 C's, a double bond O, and then NH2. So that is propanamide, and that's got 4. Butanamide is going to be 4 C's, double bonded O. Butanamide is 1, 2, 3, 4. We got the double bond O, and we need the NH2. And then our other C's here. Okay, now let's see how that looks differently when we connect it to the middle of the chain. So methyl ethanamide. Eth is 2. We have a double bond O, and then we have the N, and then we have a C, methyl, and we need another H in there. So here's your methyl part, and here is your ethyl part. Ethyl propanamide. So we've got P, N, and we have CH2 on this side, and our double bonded O. Okay, these basically are bonus. You will not see anything like this on the regions. The ones that they're on the terminal carbon that we just did, those you'll have to know. And the functional groups with the branched hydrocarbons at the bottom, where they talk about 2-methylpentanol, you don't have to worry about that so much, but we can draw it, 2-methyl pentanol. So the Al ending here tells you of an aldehyde. So we're going to draw the aldehyde first. Pent is 5. Remember, an aldehyde is a double bonded oxygen on an end carbon. And we also know that off the second carbon, so 1, 2, we have a methyl group. So that's 2-methylpentanal. And the other one that you have there So one thing that we know right away is that this tells us it's an alcohol, and we also have a methyl group. Our parent chain is 3, so we know that it is a prop and all, because alcohols are OL ending. We have to say where that OH is. It's on the second carbon, and we also have a methyl group on the second carbon. So this is 2-methyl 2-propanol. Okay, and that's it for functional groups. Look for a review just on functional groups, naming and writing branched and straight-chained hydrocarbons, and that will be for our test later this week. And then the second half of organic will just be the organic reactions.